Welcome. So we're going to go through the rational root theorem. Now the rational root theorem is a bit fiddly, it's a bit tricky, but hopefully you give me your full attention here and you can walk away feeling confident with the process. So it says, consider this polynomial right here, 2x cubed minus x squared minus x minus 3. Now if you were asked to factorize this, you would first begin by using the factor theorem, in which you're going to sub in numbers into it until you get 0 out, and that means you've found a factor. And you're not just going to sub in any number into it, rather you're just going to consider the factors of the constant here. So the constant term leads us to try p of 1, p of -1, p of 3, and p of -3. So you sub all of those in, hoping that one of them gives you a 0. However, none of these are equal to 0. And now you would start freaking out. You'd be like, well, what on earth do I do now? None of these give me 0, so what on earth is my factor going to be? So let's keep reading here. It says, therefore, the root is not an integer. The word root here is simply a number that you sub in that gets you 0 out. So the root is not an integer. It's not 1, it's not -1, it's not 3, it's not -3. So numbers that you sub in that get you 0 out is called a root. So that means our root is not going to be 1. It's not going to be -1. It's not going to be 3. It's not going to be -3. Our root is not an integer, which means the factor cannot be written like this. So you can imagine if the way that you'd write this as a factor would be x minus 1. That's not going to work. X plus 1, x minus 3, x plus 3. This is what your factors would look like, which we've seen before. None of these are working, therefore. None of those are factors. So this leads us to the conclusion. If the root is not an integer, what other options do we have? Well, perhaps the root is a rational number. And a rational number is simply a number that is written as a fraction, as you can see here. So x is equal to alpha over beta. So perhaps this is the case. Now, if this is the case, that is written like this, how would we therefore write this as a factor? Well, you would multiply both sides by beta. So you get beta x is equal to alpha. Then you would minus alpha from both sides. So beta x minus alpha is equal to 0. And this right here would be what your factor looks like. So in which case, the factor would look like this. So beta x minus alpha. Okay, so what we just gone through there, we just went through something really important. We've just gone through the thinking behind using the rational root theorem. So the rational means it's going to be a fraction. So the root is going to be rational, the rational root theorem. So we begin by doing what we normally do, subbing in factors of the constant until we get 0 out, but nothing gave us 0 out. So that leads us to the idea that perhaps the root isn't an integer, perhaps it's a rational number, perhaps it's a fraction. So to determine whether this is the case, sub in the following rational numbers into p of x. So now we have to sub in rational numbers into p of x to see if any of those result in 0. But we're not just going to sub in rational numbers willy-nilly, would be there all day. Rather, what we're just going to consider are factors of our last term, which we're going to call alpha, and factors of our first term, which we're going to call beta. So that means our numerator here, so alpha, our numerator, is going to be factors of the last term, 3. So it's going to be plus or minus 1, plus or minus 3. And then our denominator is going to be factors of our coefficient of the first term here, which is 2. So factors of the first term, so plus or minus 1, plus or minus 2. Perfect. So now what we're going to do is say, well, if my numerator is 1, my denominator could be 1, or my denominator could be 2. So if my numerator is 1, I could have a denominator of 1 or 2. And so too, if my numerator was 3, I could have a denominator of 1, or I could have a denominator of 2. Perfect. So there are all the options before us. Now we can actually eliminate some of these because 1 on 1 is an integer because it's just 1. So get rid of it. And 3 on 1, that's just an integer as well. That's just 3. So we can get rid of it. So that means the only things we need to consider are this one and this one. Those are the only rational numbers that we need to sub into this to make it work. Now I don't want to be here all day, so I'm actually going to cheat here a little bit. So our step 1 is going to be trial and error. Trial and error. That's our step 1. So what we're going to do is we're going to go p, and we're going to start off with a half. Now, if you were to do this, you would find out that it does not work. You'd have to do it by hand. It would take a long time. So I'm just going to cheat it a little bit. I apologize. Then you'd do it here. And you'd do it and you'd find, hey, that doesn't work either. And then you'd go to your next one. You'd go 3 on 2. And guess what? That one would work. When you put p of 3 on 2 in, that's going to work. So that means our root is going to be x on 3 on 2. Now you'd now you'd rearrange it to get it into your factor form. So you'd go 2 of x is equal to 3. And then you'd go, you'd go 2x minus 3 is equal to 0. Therefore, 2x minus 3 is a factor. Perfect. So let's highlight that. So this is the trial and error step. It's the horrible step. You're just subbing in numbers until you get 0 out. Perfect. So we found it. And I might even highlight this one. All right, next, step 2. So step 2, just as a normal example would be, is we do division. To find our other factor now, we have to divide. So let's come here, let's come here. So we're going to take what we found, so 2x minus 3, and we're going to divide that by p of x. Now p of x is 2x cubed minus x squared minus x minus 3. Let's do some division. Now you might freak out initially because our divisor is non-monic, but it actually works out fine. So this is going to be x squared because 2x times x squared is 2x cubed, so 2x cubed here. Then this will be negative 3x squared, this brackets brackets minus. This is going to be 2x here, or 2x squared rather. And then I bring down this minus x. Then we start again. 2x times what will give me 2x squared? Well, that's just going to be plus x. Then I get 2x squared here minus 3x, brackets, brackets, minus. This is going to go away. This is going to be 2x, and then I bring down this to minus 3. Then I go 2x times what gives me 2x? Well, it's just going to be 1. Then I go 2x minus 3 is going to be 0. Remember, it's really, really important that you get a remainder of 0. This had to be your remainder. If you didn't, it means you did something wrong. Because remember, we found that 2x minus 3 was a factor. So if you didn't get 0 out, something has gone wrong. Okay, perfect. We are nearly there, guys. Hopefully you're holding on. All right, step 3. Factorize quadratic. So these are the 3 steps that we normally follow. Now, it's important to realize that you factorize the quadratic if possible. Sometimes this ain't possible. And in this case, it actually ain't possible. So we come here. We've got 2x minus 3. So remember, we're factorizing p of x. P of x is this, and we know it's going to be our divisor multiplied by our quotient, x squared plus x plus 1. Now, what we need to do is see whether or not we can factorize this quadratic. So our product would have to be 1, our sum would have to be 1, and what would the factors be for this to happen? And quite clearly, it does not work. So, can't factorize. And actually, I've kind of jumped to that conclusion too soon. Before you could say you can't factorize, what you would first have to do is consider the discriminant. Wouldn't you? You can't just leap to that conclusion, because just because you can't do it in this way, you could still complete the square, and there are other options that you could use. So you actually have to use the discriminant to prove it. So I'm going to go, b is 1, so it's going to be 1 minus 4, a is 1, c is 1, so it's just going to be negative 3 here. So therefore, can't factorize. So it's really important that you don't just kind of leap to the conclusion if this doesn't work. You have to show me using your discriminant there. So guess what? Guess what? My answer is 2x minus 3 x squared plus x plus 1. That is my answer. That is my answer. Because that's as factorized as I can get it. That quadratic at the end doesn't factorize, so this is as good as it gets. that is the rational root theorem, guys. It is a long and painful process. Hopefully it makes sense and you understand why you would use it. With that, I'll say goodbye. I will go through some more examples in the next part. I'll see you soon.